Is it audible?
Yes, sir.
Yes, sir.
Okay. In the last class, as we are discussing about break point of chlorination, right? Up to that we have discussed. Today we are going to discuss the by using the chloramine. By using chloramine, how this wait a minute. Yeah. Okay, by using chloramine, how we are going to remove this pathogenic bacteria present in the water. Okay, it is obtained. How we are going to obtain this chloramine? NH2. The formula for the chloramine is NH2Cl. NH2Cl is the formula for the chloramine. How we are going to obtain this? How we are going to prepare this chloramine is it is obtained by mixing chlorine, okay, and ammonia. Chlorine and ammonia. It is in the 2:1 ratio to form the stable chloramine, which generates hypochlorous acid. This hypochlorous acid, already you know this. Okay, the preparation of this chloramine is Cl2 NH3. Cl2 NH3, it gives NH2Cl. NH2Cl plus HCl. Okay, this NH2Cl, when we add in H2, okay, water, NH2 reacts with NH2Cl. We are going to add in H2O. It forms H4Cl, hypochlorous acid plus NH3 amine. Okay, this hypochlorous acid, okay, H4Cl called hypochlorous acid. Okay, same thing. It acts as a powerful, okay, the strong oxidizing agent acts as an, okay, powerful germicide, okay, which kills the pathogenic bacteria present in the water. Okay, hypochlorous acid acts as a strong oxidizing agent. Okay, it kills the hypochlorous acid, inactivates the enzymes of bacteria and kills the bacteria. So it acts as a powerful germicide. It is better bactericidal action than chlorine. Okay, it has better bacteria means germicidal action than the chlorine. So it is the more stable and not produce any irritating odor. So it is hypochlorous acid is a more stable form than chlorine. So it does not produce any irritating odor. Okay, this is the preparation. Chlorine reacts with ammonia. It forms chloramine. Okay, in the ratio of 2:1 ratio, it forms HCl as a byproduct. NH2Cl plus it reacts with H2O, gives H4Cl, hypochlorous acid plus NH3 ammonia. This hypochlorous acid acts as a strong oxidizing agent, a powerful oxidizing agent. It kills the, okay, pathogenic bacteria present in the water. Pathogenic bacteria present in the water. Okay, example, chloramine is useful for the disinfecting swimming pools. Okay, one of the example is given. It is commonly seen in this type of, okay, useful for the disinfecting swimming pools. Okay, next. Okay, disinfection by ozone. Here already you know that ozone, how we are going to prepare. The formula for ozone is O3. Okay, it is a excellent and harmless disinfectant. Ozone acts as an excellent and harmless disinfectant since it produces nascent oxygen. Okay, this O2 plus oxygen. Okay, this is, we call it as nascent oxygen, which is unstable, highly unstable. This nascent oxygen is highly unstable. Okay, and it acts as a powerful oxidizing agent. It acts as a powerful oxidizing agent. Okay, it oxidizes organic matter present in the water. And kills the bacteria present in the water. It oxidizes organic matter present in the water and kills the bacteria present in the water. See how this we are going to pass this ozone into the water. This is a formula how we are going to prepare this nascent oxygen. O3 gives rise to O2 plus nascent oxygen. Here, nascent oxygen acts as a powerful oxidizing agent. It oxidizes the organic matter present in the water and also kills the bacteria present in the water. Now, disinfection by ozone. How we are going to inject this ozone into the water? Okay, here ozone is injected into the water and allowed to come in contact in sterilization. Ozone is injected into the water and these two are allowed to come in contact in sterilizing tank for about 10 to 15 minutes. Okay, the disinfected water is removed from the outlet at the top of the synthesizer. Okay, sterilizer. Disinfection of municipal water. Okay, this is not useful for the disinfection of municipal water. The reason is it is a expensive method. Okay, here this method is not useful in the treatment of municipal water because this method is one of the expensive method. Okay, it is one of the costlier method. So disinfection of municipal water is not done by using this method. Okay, here what we are going to do means we are injecting this ozonator is there. Ozonator. Okay, here from this ozonator we are passing the ozone. Ozone here we are passing ozone gas O3. O3 is passing through this pipeline. Okay, from the top. Okay, water inlet. This is a water, raw water. Okay, means it contains pathogenic bacteria present in the water. Raw water we are introducing from this side. Okay, from this pipeline. Okay, we are passing the ozone O3. Now it reacts with. Okay, same. It reacts with this ozone. Okay, ozone. What happens? Ozone forms O2 plus O3. O2 plus O, this is nothing but nascent oxygen. This nascent oxygen acts as a powerful oxidizing agent. Okay, it kills the bacteria present in the water and whatever the water that is coming out from this is water outlet. Okay, this is a pure form of water. Pure form of water. Okay, sterilized water, the top of the sterilizer. Okay, disinfected water is removed from the outlet at the top of the sterilizer. At top of the sterilizer. Okay, this process is not done for the treatment of municipal water because it is expensive method. Expensive method. Okay, this is about water treatment process. Okay, we are taking the raw water from the river. We are now we are sending filtration. We are doing the filtration. Next to coagulants. By adding the coagulants, we are removing the organic matter present in the water. And the next to segmentation followed by disinfection by different methods, and next to treated for storage, water storage, next distribution for the consumption, how household distributions. This is the process of water treatment. Okay, water treatment process. Next, coming to the desalination. What is desalination? Removal of dissolved salts present in the water. The process of removal of dissolved salts, that is like NaCl, okay, present in the water. Dissolved salts, NaCl present in the water, is known as desalination. Desalination. How this we are going? Okay, this is done by several methods. Okay, but in our syllabus we have reverse osmosis method. Reverse osmosis. By doing the reverse osmosis, we are going to perform the desalination of seawater. Or okay, here coming to the desalination of brackish water. How we are going to desalinate the brackish water? Brackish water. Okay, what actually this brackish water? Water is of three types. Okay, here water is divided into three categories on the basis of salinity. One is sea water and brackish water and fresh water. Okay, sea water, brackish water and fresh water. What actually the sea water is? Okay, if the salinity means percentage of salt content present, salts present in the water. If the salinity is greater than 35,000 milligrams per liter, it is called as sea water. Okay, water is divided into three categories on the basis of salinity. Okay, based on the salinity, it has been categorized into three types. One is the sea water, and the brackish water, and the third one is fresh water. Yeah, coming to the sea water, if the salinity is present is greater than 35,000 milligrams per liter, then it is called as a sea water. Okay, the salinity is in the range of 1,000 to 35,000 milligrams per liter. Okay, then it is called brackish water. It is a peculiar salty taste. Okay, so it is not suitable for drinking. Brackish water and the fresh water. Okay, this water we are going to drink, fresh water. The salinity of water is less than 1,000 milligrams per liter. It is called as a fresh water. Depending upon the present of this salinity, basis of salinity, it has been categorized into three types. One is sea water, brackish water, and fresh water. Okay, greater than 35,000 milligrams per liter, it is called sea water. Okay, in the range of 1,000 to 35,000 milligrams per liter, it is called as brackish water, and it is a peculiar salty taste. And if it is a salinity of water is less than 1,000 milligrams per liter, it is called as fresh water. Here, see, brackish water and sea water are not fit for drinking, means not suitable for drinking as well as industrial purpose. Okay, now this we are going to do this sea water and brackish water is subjected to desalination. Okay, to make them to suitable for drinking, because these are not suitable for drinking. We are doing desalination for the brackish water and the sea water. Okay, desalination of brackish water. It makes them, okay, whatever the unsuitable drinking water becomes suitable for drinking. Now, what actually the desalination of brackish water is? Here, water containing high concentrations of dissolved salts. Okay, already you know that it contains greater than, okay, greater than 35,000 milligrams per liter. Greater than 35,000 milligrams per liter. So it is called as a with a peculiar salty or brackish taste is called as the brackish water. Here, sea water is an example for the brackish water, as it contains 3.5% of dissolved salts. 3.5% of dissolved salts. Before the removal of these salts, okay, it is unfit for most of the domestic and industrial applications. So this process of removal of dissolved salts, okay, this is nothing but desalination. The definition of desalination is the process of removal of dissolved salts like NaCl present in the water is called desalination. The process of removal of dissolved salts present in the water is known as desalination of brackish water. Desalination. Okay, now there are techniques involved in the desalination of brackish water, like reverse osmosis. The first one is reverse osmosis. Reverse osmosis, electrodialysis, distillation, and freezing. But in our syllabus, we have only reverse osmosis. Reverse osmosis method. The technique involved for the desalination of brackish water is reverse osmosis, electrodialysis, and distillation and freezing. How? By using this reverse osmosis, how we are going to remove this salt water, okay, into the fresh water. Now coming to the definition of osmosis, what actually the osmosis means? Okay, when two solutions of unequal concentrations are separated by semi-permeable membrane. Okay, when two unequal solutions of unequal concentrations, okay, two solutions of unequal concentrations are separated by a semi-permeable membrane, okay, which does not permit the passage of dissolved solute particles. Okay, which does not permit the passage of dissolved solute particles like molecules and ions. Flow of solvent takes place from the, okay, flow of solvent takes place from the dilute to concentrated solution. Okay, flow of solvent takes place from the dilute solution to concentration solution, means low concentration solution to the high concentrated solution. This process is called osmosis. Now, okay, the process of momentum of particles from the low concentration to dilute, means dilute contains the less concentration to more concentrated solution is called as osmosis. Here in this process, only solvent can flow but not solute. Okay, if you take in a beaker. Okay, it contains solute and solvent. Okay, solute is nothing but solute, solvent gives rise to solution. Here only the solvent can flow but not solute. Okay, flow of solvent can takes place but not solute, which produces the osmotic pressure. Okay, which produces osmotic pressure on the side of the more concentrated solution. Here, only the solvent can flow but not solute. Solvent can flow but not solute. You see in the picture, dilute solution containing high concentration of water molecules. Okay, this is a permeable membrane. Okay, semi-permeable membrane. Okay, it is made up of cellulose acetate. Okay, it helps in the momentum of particles from the one chamber to another chamber. In this process, only solvent can flow but not solute, which produces a pressure. Okay, during this process, it produces a pressure that is called osmotic pressure on the side of more concentrated solution. On the side of more concentrated solution. Okay, what is osmotic pressure? The pressure created by the water moving across the membrane. Okay, the pressure created by the water moving across the membrane due to the osmosis is called osmotic pressure. Okay, what is osmotic pressure means? The pressure created by the water. Okay, the pressure created by the water moving across the semi-permeable membrane. Okay, here the membrane is nothing but the pressure created by water moving. Okay, the water moving across a membrane, that is semi-permeable membrane, due to the what? Due to the osmosis. Okay, due to osmosis is called osmotic pressure. It's called osmotic pressure. Okay, this due to this osmotic pressure, okay, the only solvent can flow but not solute, which produces a pressure called osmotic pressure on the side of more concentrated solution, more concentration. Okay, here the process by which the flow of solvent takes place. Okay, the flow of solvent takes place from the region of low concentration to high concentration when two solutions of different concentrations are separated by semi-permeable membrane. Okay, the flow continues till the concentration is equal on both sides. Okay, this flow is continuously takes place till the concentrations will become equal. Okay, equal on the both the sides. See here the partially, okay, this semi-permeable membrane dilute solutions containing high concentrations of water molecules. See in the here it contains high concentrations of water molecule, high concentrations of water molecule is present. Okay, in here concentrated solution with low concentration. Here only few number of these low concentrated solutions are present. Okay, here this is separated by semi-permeable membrane. Okay, the pressure that is created on the concentrated, okay, the pressure created by the water moving across the membrane due to osmosis is called osmotic pressure. Okay, here the flow continues till the concentration is equal on the both the sides. This type of momentum of the water molecule continuously takes place. Still the concentrations on the both the sides should be equal. Till that time it has been continuously takes place. Okay, see here the osmosis for the water molecule motion takes place. Here this is a less concentrated and this one is a semi-permeable membrane. Here the blue color one is the water molecules. The flow is continuously moving till the water molecules become equal on the both the sides. Now coming to the principle involved in this osmotic pressure. Okay, here reverse osmosis we are doing in a reverse way, that is nothing but reverse osmosis. So what actually the osmosis says means Okay, here the process of flow of solvent from region of low concentration to high concentration when two solutions of different concentrations are separated by semi-permeable membrane is called osmosis. But here we are doing in a reverse way. That is a reverse way. That is nothing but reverse osmosis. Reverse osmosis. Here, if the hydrostatic pressure is the excess of osmotic pressure is applied on the concentrated side, there diluted side, but we are doing on the concentrated side. Now what happens? Applied on the concentrated side. Okay, here osmotic pressure is applied on the concentrated side. The flow of solvent reverses as it forced to move from concentrated side to the dilute side. Okay, it is in a reverse way. Okay, it is happening in a reverse way across the membrane. This is the basis for the reverse osmosis. Actually, it should be from the low concentrated to, okay, the flow of solvent must be from the low concentrated to the high concentration. But here, as the hydrostatic pressure is applied in excess of osmotic pressure, what happening means the concentrated side, the flow of solvent reverses as it forced to move from concentrated side to the dilute side. Okay, it is happening in a reverse way. It is happening in a reverse way. So it is the basis for the reverse osmosis. Okay, thus reverse osmosis, pure water is separated from the contaminated water. See here, the actually this concentration of water molecule is very low on this side. Okay, this side, but here the concentration of water molecule is high. Okay, but we are applying the osmotic pressure. Osmotic pressure is applied here. Okay, the flow of solvent reverses. Okay, it is reverses the force to move from the concentrated side to, from this side to you are applying the osmotic pressure on the concentrated side. So the solvent, the flow of solvent reverses. Okay, it is moving in a reverse direction. Actually, it should be reverses to move the from the concentrate. Okay, reverses to move the from the concentrated side to the dilute side across the membrane. Okay, it helps to the basis for the reverse osmosis. Okay, by this we are going to separate the, okay, fresh water, okay, pure water from the contaminated water. So salt water contains the contaminants. Okay, from this we are going to separate, okay, pure water from the contaminated water. Okay, the membrane filtrations is also called as superfiltration or hyperfiltrations. Okay, superfiltration or hyperfiltration. Okay, method for purification. Here the salt water is forced through the semi-permeable membrane. See, this is the osmosis process. Okay, reverse osmosis process. Here what happening means the salt water, okay, here salt water, this is brackish water or the sea water, that is nothing but the salt water over here. Salt water which is contain high concentrations. Okay, forced through the semi-permeable. Okay, we are forcing the salt water through the semi-permeable membrane. Okay, this is the salt water, and this was a pure water. This is a pure water. We are doing osmosis and reverse osmosis. What happening? Actually, the osmosis has to happen from the low concentration. Okay, in this picture, it is clearly explanation. Okay, here actually this is the pure water. Okay, low concentration to high concentration has to be taken place. That it is nothing but osmosis. But here this is happening in a reverse direction. Okay, it is happening in a reverse direction. That is from the high concentration to low concentration. Okay, so it is a reverse osmosis through the semi-permeable membrane. Okay, the semi-permeable membranes are made up of by applying this osmotic pressure. The pressure greater than the osmotic pressure is applied on the high concentrated solution through, okay, this in the presence of semi-permeable membrane. Okay, it here the semi-permeable membranes are made up of cellulose acetate, polymethyl acrylate, and polyamides. Here water is forced through the semi-permeable membrane, which is made up of very thin thin films of cellulose acetate. Okay, these membranes are made up of thin films of cellulose acetate. Here, superior membranes made up of polymethyl acrylate and polyamide polymers are also used. Okay, the membranes are made up of polymethyl acrylate and the polyamide polymers are also used. This semi-permeable membranes is a selective membrane which does not permit the passage of dissolved solute particles. Okay, does not permit the passage of dissolved solute particles. Only the solvent particles can move through this semi-permeable membrane. Okay, the momentum of from the high concentration to low concentrated solution. Okay, a brackish water becomes the salt water, which is contaminated water, becomes the fresh water. Okay, the water by applying the osmotic pressure, where we are converting this salt water into the fresh water. Okay, in the presence of semi-permeable membrane. Semi-permeable membrane, selective membrane which does not permit the passage of dissolved solute particles. Coming to the reverse osmosis, okay, it is a very easy process and it is used to make pure water. Okay, from the raw water or salt water, you're going to convert into pure water. It removes the ionic and non-ionic substances present in the water. By using this method, we are going to convert, okay, removes the ionic and non-ionic substances present in the water. Okay, here it is also used to remove the suspended and colloidal particles. Okay, here you remove the suspended and colloidal particles present in the water. Okay, here the life of membrane is, okay, this semi-permeable membrane life period is 2 years. Okay, then after we need to change this semi-permeable membrane. Okay, life of this semi-permeable membrane is up to 2 years. Then it should be replaced with fresh one. Okay, by this process, what sea water is made for drinking purpose, made fit for drinking. So water obtained after being treated by this process is used in the boilers. Okay, boilers are nothing but they are in the industries. These boilers are used for the steam generation. Whatever the steam that generates in the boilers are used for the generation of electricity. Okay, generation of electricity. Steam generators. Okay, the steam that generated in the boilers are used for the production of electricity. Now coming to this same, it is applicable mainly for the this reverse osmosis method is mainly applicable for the desalination of seawater and brackish water. Here it consists of the chamber fitted with semi-permeable membrane. Okay, this reverse osmosis cell consists of a chamber fitted with semi-permeable membrane, above which seawater or impure water is taken. Same. See here in this. Okay, we in the top we are taking the sea water or brackish water taken, and impure water is taken, and the pressure of 15 to 40 kg per centimeter is applied on the sea water for separating the pure solvent, pure water from its contaminants. Okay, what we are doing in the reverse osmosis cell consists of a chamber fitted with semi-permeable membrane. Okay, above which seawater, impure water is taken, and the pressure of 15 to 40 kg centimeter square is applied on the seawater for separating, okay, pure water, okay, pure solvent from its contaminants, This is the reverse osmosis. Actually, the osmosis has to be This is the process of osmosis by applying the osmotic pressure. Okay, the pure water become, okay, here the water flow semi-permeable membrane, but we are applying in a reverse direction, low concentrated to high concentrated, but this is from this side, high concentration. Here, this semi-permeable membrane is, okay, this salt water or contaminated water becomes the fresh water, pure form of water. Now coming to the advantages of this reverse osmosis. What are the advantages of reverse osmosis? Okay, in this process, we by using this process removes the ionic and as well as non-ionic dissolved salts present in it easily. Okay, by using this, we are going to remove the ionic as well as non-ionic dissolved salts easily, and it is effective in removing colloidal impurities. Okay, suspended and colloidal impurities can be removed by this process. Example, SiO2. The process is economical, okay, and convenient. It can be carried out at room temperature. This process can be carried out at room temperature. Okay, it is suitable for converting seawater into the drinking water. Seawater into the drinking water. This can be used for the water that is coming from this by using this reverse osmosis method is used for the high pressure boilers. Okay, these are the advantages. And coming to the applications, okay, here the treatment of wastewater can be done by using this reverse osmosis, desalination, purification of water. Okay, in this making proceeded water in dialysis in hospitals. Okay, certain cosmetics and drugs by pharmaceutical manufacturers for injections. Okay, water for injections. Okay, these are the applications of reverse osmosis. Applications of reverse osmosis. Now, this is about water technology. Water technology. Up to here is a water technology. Next module is the engineering materials. Small introduction part we will need to discuss here. What actually this in this engineering materials module 3, the syllabus we have in up to the CIE is introduction to polymers. Engineering materials we have introduction to polymers. Okay, polymers and classification with examples. Okay, how the polymers has been classified. Okay, next types of polymerizations. Types of polymerizations, we have addition, condensation, and copolymerization. And plastics. In the plastics we have thermoplastic resins and thermosetting resins. Compounding of plastics, synthetic polymers. Okay, synthetic polymers. In that synthetic polymers we have polyvinyl chloride, PVC, nylon 66, Teflon, and bakelite. Okay, this is the synthetic polymers and the biodegradable polymers by using the microorganisms. Okay, enzymes present in the. Okay, we are going to prepare the polymers is nothing but biodegradable polymers. This is the engineering material syllabus for the CIE 1. Okay, coming to the what actually the polymer is. Okay, what is a polymer? In the 15th century, Christopher Columbus is noticed that the natives of South America were playing with the bouncing balls. Okay, they are playing with the bouncing balls, which is made up of latex of tree. Okay, latex of tree, which he called as weeping woods. Okay, used to call weeping woods. This natural rubber, which was named by Joseph Priestley as rubber. Why he called it as a rubber means as it is erasing the pencil marks from the paper. As it is erasing the pencil marks present on the paper, so he called it them as Joseph Priestley called it as rubber. Okay, here in the 15th century, Christopher Columbus noticed that South America were playing with the bouncing balls, which is made up of latex of tree, which we called as weeping woods. Okay, this national rubber, which we called it as rubber by the uh, Joseph Priestley. Now, later on in the year 1909, Leo Baekeland. Okay, Leo Baekeland developed the phenol formaldehyde resin. Okay, phenol formaldehyde resin, and it is called as Bakelite. He has been called the father of plastic industry. Okay, 1909, Leo Baekeland developed the phenol formaldehyde resin and named it as Bakelite. He is called the, okay, this Leo Baekeland is called as the father of plastic industry. This is the father of plastic industry. Now coming to the polymers. Okay, polymers. What are the important? Okay, how they are useful in our daily life? How the polymers are useful in our daily life? It is important. The polymers form very important components in our daily life. Okay, because the polymers are highly useful in domestic purpose. Okay, in the domestic, industrial, and medical fields. It is useful in domestic purpose, industrial purpose, and medical fields. Okay, the following are the reasons for the extensive use of polymers. What are the reasons why we are using the more in our daily life? Okay, extensive uses of polymers, because most of the polymers are non-toxic. Okay, most of the polymers are non-toxic and it is safe to use. Okay, the reason why we are using in our daily life means these polymers are non-toxic. Okay, it does not cause, it does not harmful to anyone. Okay, so the reason is non-toxic and we can use safely. It is safe to use, and it has a low density. Low densities, that is nothing but light in weight. Okay, light in weight, so we can transport this polymer very easily from one place to another place. Transportation will be easy. So because of low density, density is nothing but light in weight, so the transportation will be easy, and they possess high strength, good flexibility, and resistance to chemicals. Okay, they are high strength. It possesses high strength, flexible. Okay, can flexible, and resistance to chemicals. Resistance to chemicals. Already you know it functions as a good thermal and electrical insulators. Okay, here the rubbers are acts as insulators. It does not allow the electric current to pass through them. Okay, so we call it as good thermal properties. Okay, these rubbers have good thermal and electrical insulators. Acts as a good thermal and electrical insulators, and it can be molded and fabricate easily. Okay, we can mold these rubbers and fabricate easily, and they possess aesthetic colors. Aesthetic means beautiful colors. Beauty, aesthetic sense is nothing but beautiful colors. Okay, beautiful colors they possess, so it is called as polymers. Polymers, these are the reasons why we are useful in our daily life. The reason behind this, these are non-toxic, safe to use, and the next one is low densities. Okay, light in weight, so that because of low density, okay, light in weight, we can transport these polymers from one place to another place very easily, and it has high strength. Okay, high strength is there. Flexibility will be there, good flexibility, and it can resistant to chemicals. Okay, and it acts as a good thermal and electrical insulators, and we can mold these rubbers, uh, molded and fabricate properties it have. They possess aesthetic colors. Aesthetic colors. This is the reason it is very important in our daily life, and is also useful in domestic, industrial, and medical fields. Domestic, industrial, and medical fields. Okay, this is about the introduction part. Now we'll discuss the next remaining classification of these polymers from how we are going to derive. Okay, the polymer is a Greek word. Poly means many, and mers are nothing but units or parts. Okay, it has been polymer is a Greek. Poly is nothing but from the Greek. It's derived from the Greek word poly. Okay, poly is the derived from the Greek word which means many, and mers are nothing but units or parts. Units are parts. So we call the definition of polymers is large molecules are formed by linkage of small molecules. Okay, means or several monomers are united together to form a large molecule is called as a polymer. Example, polyethylene. Okay, ethylene. Here the ethylene is a monomer. This many monomers are combined together. Okay, this repeated unit of polymer is called as a monomer. Here monomer is a ethylene. The polyethylene monomer is a ethylene gives the polymer that is the polyethylene. This is a polymer. Ethylene is a monomer. Monomer, we are going to present the NCH2 double bond CH2 is a ethylene on the presence of heat and pressure catalyst. It gives a polyethylene. Okay, monomer is a single molecule. The polymer is the chain of monomers. Chain of monomers combined together to form the polymer. We'll discuss this in the next class. And the classification of polymers we have. Okay, it has been classified into the natural polymer, synthetic polymer, and semi-synthetic polymers. Based on their origin and nature, polymers are classified into following types based on the origin, natural, synthetic, and semi-synthetic. Based on the structure, it has been classified into linear polymers, branched polymers, cross-linked polymers. Based on the molecular forces present in between the polymers, okay, they are elastomers, fibers, and these thermoplastics and thermosetting polymers. Okay, based on the polymerization mechanism, okay, there are addition polymerization, condensation, and the one is copolymerization. Okay, this we'll discuss in the next class. Yeah, you have any doubts?
Excuse me, sir.
Yeah.
It's not about the current subject, but what's the model paper for CIS? Like how long should
I will tell you because actually sorry. We don't know the exams will conduct by the next week. We came to know whether it will be in offline or online. We don't know till that time, right? If it is online, exams will also conduct in the online only. Okay, it depends upon the. Actually, they said up to 30 is online, but we don't know whether it continues or it stops. Once it will be offline, you will write the exams offline only. If it is online, you need to write exam online. So the online exam paper pattern is different. Okay, online paper pattern is different. So that is the reason. I will tell you the paper pattern.
Okay. For now, for preparing answers for the questions in question bank, like how long should our answers be?
Okay, so it is also correct, but I will. They will keep whether we don't know whether the exams will conduct online or offline. Earlier, for your seniors, these exams they conducted in online. Their paper pattern was different. Okay. So that is the reason they will keep, it seems, 1 or 2 days in the telegram also you will get the paper pattern.
Okay.
Okay. Otherwise I will tell you. Yeah. Yeah.
Short answers any marks? అంటే ఇప్పుడు మామూలు
యాక్చువల్ పేపర్ ఇంతకు ముందు షార్ట్ ఆన్సర్స్ 1 మార్క్ వచ్చాయి, తర్వాత 2, 3 అలా వచ్చేటి. బట్ పేపర్ ప్యాటర్న్ ఇంకా ఫస్ట్ 2 మాడ్యూల్స్ అయితే అలా ఉండేది. చూద్దాం, పేపర్ ప్యాటర్న్ మీకు పెడతారు, టెలిగ్రామ్ లో ఇస్తారు. ఓకేనా?
అంటే ఇప్పుడు క్వశ్చన్ బ్యాంక్ మామూలుగా షార్ట్ ఆన్సర్స్ ప్రిపేర్ చేసేటప్పుడు అవి లాంగ్ ఆన్సర్స్ లెక్క వస్తున్నాయి సార్. ఐ మీన్
అవును సార్, కొన్ని చాలా పెద్దగా వస్తున్నాయి.
అంటే ఇప్పుడు అవి ఎన్ని మార్క్స్ మనం తెలిస్తే మనం ప్రిపేర్ అవ్వడానికి కొంచెం ఈజీ ఉంటుంది కదా.
ఇప్పుడు మీకు షార్ట్ వస్తే షార్ట్ నే రాయండి. ఒకవేళ దే ఆస్క్ ఫర్ ద లాంగ్, యూ కెన్ రైట్ ఇన్ ద లాంగ్. లైక్ లాంగ్ ఆన్సర్స్ విల్ బి ఎర్లియర్ ఇట్ వాస్ 5 మార్క్స్, 5 మార్క్స్ and 2-3 marks, like that it was. I will tell you the 1 or 2 classes, they confirm, I will confirm it and I will tell you the paper pattern. Okay?
Okay, thank you.
Welcome. Yeah, any doubts? I am stop sharing the screen. Thank you.